Students, this is Dr. Divya. Here I am teaching you about economic importance of bryophytes. So first we are discussing about the water bryophytes. So we know that bryophytes is a group of simplest and primitive plants of a group Bryophyta. These plants occupy a position intermediate between the green Thallophyta algae and Pteridophyta. So basically, bryophyta are called as the amphibians of plant kingdom, and mosses are those plants which are having rhizoids, axes, and leaves, but are not having roots and stem and leaves. Bryophytes are mainly found in cool, moist, and wet, sandy places, and they plant commonly known as under vegetation. So in India, bryophytes are mainly distributed on Himalayan range at the height of 4,000 feet and higher above sea level. Occurrences of bryophytes on tree trunks, in the forest, damp areas, and damp rocks. Types of bryophytes: mosses, liverworts, hornwort. Importance of bryophytes: first, ecological importance; second, economical importance. So their economic importance is different in different fields such as in medicinal uses of bryophytes, antibiotic activities of bryophytes, bryophytes in experimental botany, as a source of food and as a pollution indicator, and as a ecological uses. So in economical importance of bryophytes point of view, source of fuel in horticulture, preservative agent, household use, household construction, pharmaceutical industries, and moss industries. So bryophytes as a fuel first. So liverworts and mosses have long been tried and used as a fuel in developed countries like Finland, Sweden, Ireland, West Germany, Poland, and Soviet Union. And peat, a brown soil-like material of boggy acid ground consisting of partly decomposed vegetable matter. Peat is suitable for production of low and intermediate BTU gas as well as the hydrogen ethylene, natural gas, methanol, and Fischer-Troppic gasoline. Peat mosses are best suited for the production of methane, and peat is likely to become an important source of fuel for production of heat, methane, and electricity in the future. And medicinal uses of bryophytes, what had reported to the medicinal uses of Markinsia polymorpha and few species of Jaggermania, Anthiceros, and Rixia. So Markinsia polymorpha, Rixia, Anthiceros. Medicinal uses for help to cure ringworms, and ashes of moss is mixed with the honey and fed to treat outs and cuts, burn and wounds. Medicine, cystis, bronchitis, cardiovascular system, tonsillitis, tympanitis. So wherein mentioned only Polytrichum juveniparum in this connection. It mentioned that among liverworts, Markinsia polymorpha has been used to cure pulmonary tuberculosis affections of the liver. Hartwell reported that extract of Markinsia polymorpha, Markinsia striata, and Polytrichum communis possessed anti-tumor properties. So, and the dried sphagnum is boiled in water, and the decoction is used in the treatment of acute hemorrhage and disease of eye. Tea made of Polytrichum communis helps to dissolve stones of kidney and gallbladder. Antibiotic activities of bryophytes. Hayes reported that aqueous extract of Cornocephalum conicum is antibiotically active. Cornocephalum conicum and Dumortieria. Hirsuti is active against Candidata albicans. Extract of a species of sphagnum inhibited the growth of Sarcina lutea. Gupta and Singh reported the petroleum ether extract two species of mosses, namely Burbula, and are antibiotically active against 33 bacterial species, which include gram-negative and gram-positive and acid-fast bacteria. Water retention. So bryophytes have a high water retention capacity due to their structure and tend to be most abundant in regions with high level of atmospheric humidity and low rates of evaporation. They can quickly absorb water and release it slowly into surrounding environments, and can therefore contribute the retention of humid forest microclimate and the regulation of water flow. Perhaps More importantly, these properties allow forests to gradually release water into watercourses and preventing flash flood, erosion, and landslide downstream. And the water retention properties of bogs are particularly impressive because of the absorptive properties of sphagnum mosses. A bog within a watershed, as can be found on some upland moorlands, is more important far beyond its own geographical extent. If such a bog is unable to function, and the disruption of the local hydrology can be catastrophic. So this figure shows the diagram of sphagnum species. Water erosion and nutrient recycle. So water erosion and nutrient recycle. So bryophytes on tree trunks absorb rainwater that's flowing down the trunk, and those hanging like curtain absorb water and both from rain and help maintain in a humid atmospheric, and so greatly influences of the microclimate. And bryophytes will also trap any nutrient that are dissolved in the rain and mist droplets. So in many cases, so trapping nutrients that would be otherwise will be washed out, and living bryophytes make use of the nutrient they trap, and dead decaying bryophytes release nutrient to the surrounding plants. So in this type of a ways, bryophytes plays an important role in nutrient recycling. Second role is soil conservation. So bryophytes form a mate and prevent soil erosion, and they intervene moss stems and rhizoids bind soil particles firmly and hold large amount of water and reduce runoff. Peat formation. So peat is a brown dark color spongy matter produced due to compression and carbonization by deposit in water. Sphagnum and other mosses form peat. So it is used in horticulture, making ethyl alcohol and illuminating gases. Pie chart showing peat uses as a fuel. So share of Ireland's indigenous energy supply in 2019. This diagram shows how peat used as a fuel. Colonization, soil stabilization, and accumulation of humus. So mosses are often the first plant to colonize newly exposed ground, bare rocks, and other abatic surfaces. So they are more important in stabilizing the soil crust, both in recent established and existing habitats such as a steep sloping banks in woodlands. So they are also valuable in controlling erosion and hydric cycling. So in semi-arid woodland, bryophytes play important role as a colonizer, soil stabilizer in areas where soil surface conditions have declined as a result of increased infiltration. So in the tree canopy in tropical forests, where the soil often lacks a humus layer and is poor in nutrients. So bryophytes basically assist in accumulation of humus on branches and twigs. Epiphytic humus accumulated by Bryophyta can amount to such as much 2.5 ton of dry matter in alpine cloud forest of East Africa. Bryophytes in experimental botany. So the liverworts and mosses have played an important role as a research tool in the various phases of botany, such as genetics, experimental morphology, and physiology. So mechanism of sex determination in plant was discovered for the first time in liverwort, Sphaerocarpus, and Jimining and Boas studied correlation between growth form and habitat in bryophytes. Ecological importance of bryophytes. Ecological uses. So bryophytes are among the oldest land plant. Few of them have reached many commercial importance, and their usefulness is known to few. Gross Brockman, 1979, reported that there were indications of Stone Age's uses of the moss Necaera crispa, feather moss, by prehistoric man in a lake shore settlement in West Germany. So these modern uses embrace ecology, horticulture, constructions, household uses, and medicine, and even food. Food and shelter. So many animals make uses of bryophytes. Numerous invertebrates eat bryophytes, lay their eggs on them, and shelter in them. They form a vital role of the constructions material of the nest. Northern Coronaburgi frog are found near sphagnum bog. These in desert frog breed in sphagnum bog in alpine and alpine area, but move away from bog area. As a